Today we're going to be looking at factoring expressions that are, maybe a little more complicated than last time. We're going to look at some special factoring, difference of square, difference of cube, sum of cubes. We're going to factor quadratic trinomials where the leading coefficient isn't 1. We're just going to kind of fill in all the missing pieces of factoring so that y'all are ready to solve polynomials in the next few units. So the first thing, I'm going to give you the difference of squares rule, but I'm going to show you how we get it. So what we're going to do is we're going to start off looking at something like a plus b multiplied by a minus b. Okay, so I want y'all to multiply that. You FOIL first, outside, inside, last, and see how that goes for you. I'm going to freeze the screen, see what we get. And maybe you already knew the thing about difference of squares because you had it beaten into you in Algebra 2 or Pre-Cal last year, but, you go, and the outside and the inside terms are opposites of each other. And so when we add them, we get 0. And then the first so it's going to give you a squared, the last is going to give you negative b squared. So this equals a squared minus b squared. Now, if we see the difference of two squares, I'm really not sure what happened there. Yeah. If we see the difference of two squares, like a square thing minus another square thing, then we'll be able to factor it with a plus b and a minus b. Okay, so that's the relevant rule here. I'm going to take these away so it's not distracting. Okay, so when we look at x squared minus 4, I could say that that's x squared minus 2 squared. Okay, so it's a plus b, a minus b. So this will be, x with 2. Those are the two squares. So it'll be x plus 2 and x minus 2. Next, I'm going to look at 9x squared minus 16. Okay, 9x squared, there's no greatest common factor there because 3 or 9 doesn't divide 16. 9x squared is the square of 3x. Okay, so if I have 3x squared and 4 squared, I can factor that as 3x plus 4 and 3x minus 4. Alright, I'm going to have y'all try these 4, and I'll freeze the screen, and you can see if you're doing it right. But I expect the difference of squares is something that we've seen at least twice. We've seen it at least in Algebra 1 and in Algebra 2. And if you had Pre-Cal last year, then you saw it in that course as well. Excuse me, I misspoke. I only want you to do the top 2. I want you to do those top 2. We lost our notes packet over there. Okay. Okay, if you're having trouble seeing how I got these answers, you just go and think, what are these two things that are squared? What do I square to get 4x squared? Well, that's 2x squared. And what do I square to get 9? I square 3. And so the 2x and the 3, you add them, you subtract them, you multiply those binomials, and you get the difference of two squares. All right, these next two, they have a greatest common factor. So we should always be looking for a greatest common factor to factor out before we go to take the difference of two squares. Okay, so I see that there's an x to the fourth and an x squared, so that's an x squared in common. So I'm going to factor out the x squared, and I'll be left with 16x squared minus 9. I feel like that's one we've already done, or if not, it's really close to one that we just did. So that's x squared. 16x squared is the square of 4x, and 9 is the square of 3. So I'm going to say I've got 4x plus 3 and 4x minus 3. This one over here is very similar. I could take 4 powers of x and a 4, because 4 divides 36. So I'm going to take 4x to the 4, and I'll be left with, okay, I need to multiply 4 by 9 to get 36. I need to multiply x to the 4 by x to the 2 to get x to the 6. And then 4x to the 4 minus 1. Okay, I would need to multiply 4x to the 4 by a negative 1 to get negative 4x to the 4. Then 9x squared minus 1. 9x squared is a square. 1 is a square. 9x squared is the square of 3x. 1 is the square of 1. Of 3x plus 1 and 3x minus 1. Okay, before we move on to the cubes, I'm going to do one where the square is a binomial. Okay, so 9 is 3 squared minus this binomial squared. So I'm going to have 3 plus this binomial, and 3 minus the binomial. And if you felt the need to further simplify this, you could say, well, 3 plus 2x plus 1 is going to be 2x plus 4. And then, well, if I have 3 minus 2x and minus 1, because I got to distribute the negative to both of these things, you'd have negative 2x, and 3 minus 1 is plus 2. If you wanted to go even farther, okay, 2x plus 4 is 2 times x plus 2. Negative 2x plus 2 is negative 2 times x minus 1. Okay, so I have 2 times negative 2 is negative 4, x plus 2, x minus 1. You can take this as far as you want. Okay, next we're going to do sum and difference of cubes. So what I'm going to do is I'm going to just tell you that the sum of cubes, okay, if you have two cube numbers added together, two cube expressions, it's going to be a plus b times a squared, ab, b squared. Okay, this is the opposite, and this one's always positive. Good over there? All right, so let's see why this is true. Why does this work? I'm going to distribute it back out. Okay, so I'm going to have a to the third minus a squared times b plus a times b squared. Then I'm going to bring the b around. Okay, so b times a squared is plus a squared b minus a times 2 powers of b. And when I bring that over here, I'll have positive b times positive b squared is plus b to the third. Okay, these are just kind of in the way. So I'm going to say, okay, when I add these things all together, I'll have a to the third and a plus b to the third. Okay, so this is the rule for sum of cubes. For difference of cubes, I'm going to do the same thing. I'm going to tell you what it is. I'm going to show you why it works. And then I'll give you some kind of, I don't know if it's I think acronym's the wrong word, but some kind of mnemonic device to remember. All right. So we go over here, we multiply a by a squared, we get a to the third. Multiply a by ab, and you'll get a squared times b. That's going to be b squared. Okay, so a times b squared is ab squared. Okay, then I bring in the negative b. Negative b times a squared is negative a squared b. Here it's just one power of a, but two powers of b, and negative times positive is negative. And then when I multiply negative b by b squared, I'll get negative b to the third. Okay, now when I add down, I get a to the third minus b to the third. So. All right, and so what you want to remember for sum and difference of cubes is, and credit to Mr. Schuler for telling me this, because I'd kind of always said this, but never had a good thing to tell you. It's, notice it, okay, we start with this positive sign, and this one is the same, this one's the opposite, and this one's always positive. Okay, so we just say, so same, opposite, always positive. Okay, same, opposite, always positive. For sum and difference of cubes. All right, so let's do some examples of sum and difference of cubes. All right, I see right now that this is x to the third plus 5 to the third. Okay, I wouldn't expect you to know the third power of anything higher than 5. And so I know that when I have the sum of cubes, it's going to be x and 5. It's going to be x squared. X times 5 is 5x, and 5 squared is 25. Okay. And then I know it's same, opposite, always positive. Okay, so here, okay, it's going to be the same, opposite, and this one's always positive. Okay, and there we have factored it. That is nice. And then we can also, I would recommend with sum and difference of cubes, if you have extra time when you're, say, taking a quiz or a test, check your work. Because you can always just distribute it back to make sure you factored correctly. Okay, x to the third minus 27 is x to the 3 minus 3 to the 3. Okay, so I've set it up. I've got x, I've got 3. Then I'll have x squared, 3 times x, and 3 squared. Okay, remember it's starting with negative, and it's same, opposite, always positive. Same, opposite, always positive. This one down here, this one, 8x to the third is a cube, 27y to the third, also a cube. Okay, so 8x to the third is 2x taken to the third power. Negative 27y to the third, okay, that's minus, okay, that would be 3y taken to the third power. Okay, so I've got 2x and 3y. Okay, if I square 2x, I'll get 4x squared. If I multiply 2x and 3y, that's 6xy. And if I square 3y, I'll get 9y squared. Okay, again, okay, I've got a minus over here, so it's the same, opposite, always positive. Okay, I'll get you started on this fourth one, but I think this would be a good place for us to see if we're doing it right. Okay, 8x to the 6 is 2x taken to the third power, and 1 is, well, I guess it's just 1 taken to the third power. So I'm going to freeze it, and you can check against it. Yes. Okay, question was about this 4 in the previous problem. And so what it is, all right, so for difference of cubes, the general rule was that a to the third minus b to the third is a minus b, same, a squared, ab, b squared. So same, opposite, always positive. Okay, so I take the whole expression. In this case, a is 2x. And when I square a, I'm squaring the 2 and the x. So that's where I'm getting the 4x squared. But no, that is a really common question. That's why we're doing some that have that cube coefficient next to it. Because, I don't really doubt that people would get, this and this right. It's more of this number and that number that people tend to forget. They would say 2x squared and 3y squared. But you got to square everything. So that was a good question.
Wait, why can you do that?
Okay, it's kind of striking me that at this point, it might be good for us to make a little table of cube numbers. Okay, so n and n to the third. So 1 to the third is 1, 2 to the third is 8, 3 to the third is 27, 4 to the third is 64, and 5 to the third is 125. I don't know 6 to the third, so I certainly wouldn't expect you to know 6 to the third. I mean, y'all have got a nice scientific calculator at your disposal, but still, I'm looking for something that you easily recognize as difference of two cubes. Go and use your knowledge of algebra. It's not an arithmetic course, right? All right, so let's move on to the factoring quadratic trinomials where the leading coefficient is 1. All right, so there are a variety of techniques and tricks to factor this. And if I'm being honest, I don't like a lot of them. Okay? What I'm going to tell you to do is going to call back to what we did last time with the factoring by grouping, which I think is the safest and most foolproof method. Okay? When I was in Algebra 2, the advice they gave us was just look at it and just figure it out. Okay, and now obviously that's not a good strategy for factoring. Just figure it out. That's not good advice for somebody that doesn't get it in the first place either. I think they were like, okay, well, it's going to have to be 2x and x. Okay, if it's negative here, then it's going to have to be like plus and minus, and 15, it's probably going to be 3 and 5. Just figure it out. Okay, we don't like that. Okay, we want an actual set of steps that we can do. Okay, so what we're going to do is first we're going to multiply A and C. Okay, where A is the leading coefficient and C is the constant term. Okay, so 2 times negative 15 is negative 30. So we multiply to negative 30, and we're going to look for two numbers that multiply to negative 30 and add to B. Okay, so find two numbers that multiply to AC and add to B. Okay, so what are two numbers that multiply to negative 30 and add to negative 7?
Negative 10.
Yeah, okay, okay. So it's going to be 3 and 10. Which one's going to be negative, though? Yeah, the 10 will be negative because it needs to be negative 7. All right, so we've got negative 10 and positive 3. Okay, the third step, we're going to split the middle term. Okay, so it will always work this way. I mean, because that's how we found these two numbers, was that they added to negative 7. We're going to split that negative 7 into a negative 10x and a plus 3x. And we'll leave 2x squared and negative 15 the same. And then the last step is we're going to factor by grouping. So these are the steps. All right, so we're looking, what do we have in common on these first two? I see a 2 because they're both even numbers. And I see a power of x as well because I've got x squared and x. Okay, so I've got 2x multiplied by x minus 5. And then I look at the second two terms. And say I have a positive 3 in common. So plus 3 times x minus 5. And if you do it right, these will always be the same. If you've chosen the right numbers up here, I suppose. And you split the middle term. Okay, and then now I know I have an x minus 5 in common. So I'm going to factor out that x minus 5. And then I'm left with a 2x and a plus 3. Yes?
So by splitting the middle term, you're just replacing it with the, like...
Yeah, by the two numbers, yes.
Okay, and you exclude them.
Yeah, because you're getting negative 7x from negative 10x plus 3x. And moreover, if you were to FOIL this back out, you would see that negative 7x is comprised of negative 10x and positive 3x. But I would leave that, to the reader. All right, next I've got 2x squared, 11x, and 12. So I'm multiplying the 2 and the 12, that's 24. Looking for two numbers that multiply to 24 and add to 11. That's going to be 8 and 3. So I'm going to split that 11x over the 8 and 3. So I've got 2x squared plus 8x plus 3x plus 12. And I'm going to split the middle term. Okay, I already did split the middle term. Excuse me, I got distracted and, change of class. We're in the passing period now. I'm just trying to finish this recording. And so I'm going to factor by grouping. Okay, so we've got 2x times x plus 4. And then over here on the second two, I've got a 3 in common, plus 3 times x plus 4. Then I factor out the x plus 4. And I'm left with 2x plus 3. You could check this by foiling. But I'll tell you, that's how you do it. The last one I'm going to do today is this one, where we've got all three things with a negative. And I'll tell you, I'm much better at factoring things with a positive leading coefficient, so I'm just going to factor out the negative right at the beginning. Okay, and then I multiply a and c, so I'm looking for two numbers that multiply to 14 and add to 15. So that's going to be 14 and 1. And then I'm going to say, well, that's the negative of 2x squared plus x plus 14x plus 7. And then I'm going to factor by grouping. And then I'm going to factor out a 7 from this thing. And then I'll have that 2x plus 1 multiplied by an x and multiplied by a positive 7. The question was, did it matter if I put x and 14x or 14x and 1x? So what I'm going to do is I'm going to go back, I'm going to rewind this, and I'm going to switch the order. And then I'm going to factor by grouping, and I'll have 2x times x plus 7 plus, well, I don't have anything to factor out, so let's factor out a plus 1 times x plus 7. And then look, I'm left with an x plus 7 multiplied by 2x and plus 1.